Okay, hi, folks. This is our meetup. Those who have joined before last time, this is welcome, Austin Big Data AI meetup group. Can you guys hear me? Okay. Okay. So yeah, this is the part 2 of our continuing tutorial from last week. So hopefully we were able to follow on the material that was distributed, and we'll carry on from where we left off last week. And with that, this is the NLP tutorial part 2, and next one is our some scheduled meetup. We have another scheduled meetup coming August 20. That will be on time series forecasting using AI. Google manager from Cloud AI, he'll be performing. So I would encourage you to sign up for that as well, if you're interested in this topic. And then we have our sponsors, regular sponsors, Capital Factory sponsors our venue, this online access. And we work with this non-profit organization, AI for Greater Good, which we run this meetup through. So would appreciate his support. And with that, our main speaker today, we have Fatma and Pam. Those of you who have already attended or not attended the last one, maybe joining new, just a brief intro. Both of them are data science fellow at Quansight. Quansight is also a good sponsor of our meetups from time to time. And both of them are in the NLP space. They've been working there for a while, involved in different Austin-based conference. Fatma, she's from UT Austin, and then also worked her master's in Stanford. And Pamela, she's also worked her master's in UT Austin, and then also worked in, she has done some NLP too, also in Anaconda Con, very involved in that, been heavily experienced in this area for a while. So both of them, welcome. Thanks for joining us again. And it was a pleasure the last time, and hopefully we'll keep our discussion interactive as last time, but also we have a lot of things to cover. So we'll appreciate any question on the chat, and we'll try to follow up. So with that, I will hand it up over to Fatma, and let's see if we can.
All right, thank you. I'm gonna go ahead and, hi everyone. I'm gonna start sharing my screen. And let me do that. Okay, I'm hoping that worked.
Yeah.
Great. All right. Okay, let's get started. Let me get rid of this. Okay. Okay, hi everyone. Thank you for joining us today for our NLP tutorial part 2. Whether you were with us last week or not, you should have done a pull or clone from the tutorial repo on GitHub. If you haven't done so, you might want to just do it right now if you want to code along with us or follow what we are doing more closely. So we have some setup instructions for you there, and that will let you to follow along if you would like to. So a brief recap from last week. What we did last week was to go over some of the text pair processing steps using the library called NLP. We did tokenization, stemming, word embedding, which are some of the traditional steps that you will need to do to clean up and prepare your data for any kind of machine learning or deep learning modeling. And then we use one of the off-the-shelf models, a classifier from scikit-learn library, which was random forest classifier. And then we followed the steps to see how it performed and what were the things that we needed to do to run our model on our data. What we're going to do today, we are going to do the same thing, pretty much the same thing, but this time we are going to use the library called Spark NLP. and perform some of those steps in preparing the data and building a model that we implemented last time with NLTK. And this time we're going to use Spark NLP. For those of you who have never heard Spark NLP, I'm going to give you a brief overview of this, but there's too much to know about Spark NLP, and you will need to do some research if you want to learn more about it after the tutorial. Before we get to that, let's talk about why do we have multiple NLP libraries when we have NLTK and some others. One of the reasons for this is that NLTK falls short if used in production and or industrial level NLP applications. Like I mentioned last time, NLTK is a good tool to if you are just started, if you're just starting to learn about NLP, or if you are teaching NLP, NLTK is most of the time the to-go library. However, with increasing level of data that businesses and industries need to process every day on a daily basis, we need more robust tools. If we were to use an LTK in a production setting, we wouldn't get a lot of efficiency from out of. Spark NLP is one of the industrial level NLP libraries. It's not the only one, however, it's one of the most robust ones, I would say. And it streamlines many of the procedures of creating and deploying NLP applications in production. Spark NLP is built on Apache Spark and Spark ML. For those of you who are not familiar with these tools, Apache Spark is a general purpose cluster computing framework with native support for distributed SQL, streaming, graph processing, and machine learning. Spark ML is part of Apache Spark, and it provides a uniform set of high-level APIs that help users create and tune practical machine learning pipelines. Spark NLP takes full advantage of these tools on the back end and provides us a very efficient NLP library, which is open source, by the way. And Spark NLP is widely used in many industries, more particularly in health, because they have some customized tools for AI in biomedicine and health-related domains, and it seems like they are getting more popular, especially with the pandemic that we have been dealing with for the last few months. So this might be a little bit like too conceptual or theoretical. However, we will need to go over a couple of the terminology and concepts to better understand and place Spark NLP within the domain. Some of these terms are probably you might be familiar with. I'm going to be very brief, and it's definitely not everything that you need to know about these, but let's go ahead and talk a little bit about this before we get started with our implementations. Deep learning is a subfield of AI, and it is inspired by our understanding of the biology of our brains. Think about the interconnections of our neurons and how they're activated and how we learn and how we think about stuff. Deep learning, it consists of artificial neural networks that have discrete layers, almost of the time hidden layers, connections and directions of data propagation, all of which create a network that results in computational learning. Pre-trained model is a model created by others that you can use to solve a problem, specific problem that you're trying to do. This could be any kind of NLP task, or it could be vision, computer vision. Instead of building a model from scratch, what we are doing with pre-trained models is that we are using this model that is trained on a highly large amount of data, and we are using it as a starting point to use on our own data. When using a pre-trained model on our own data set, you do not have to train the entire architecture, but only a few of the last layers in your neural network. This saves you a lot of compute power and a lot of money. That's why pre-trained models have been very popular, especially in the NLP area, mostly in the last couple of years, and in the last 5-6 years in the computer vision domain. And this is where we need to talk about transfer learning. A pre-trained neural network gains knowledge from the data it is trained on, which is compiled as weights of networks. These weights can be extracted and then transferred to another neural network to perform a task. And transfer learning is basically getting knowledge and learning of another model and applying it to our own by some customizations and fine tuning based on our data and the domain of knowledge that we are trying to make it work. So basically, in other words, transfer learning is a means to extract knowledge from a source setting and apply it to a different target setting. And the reason I'm talking about all these terms is because they actually play very nicely into some of the most recent and robust tools, such as Spark NLP. And some of the pre-trained language models include, you might have heard about these models, BERT, GPT-2, XLNet, and Roberto. These are very powerful models that have been very popular lately, and people are using their weights and learning and applying it to their own data. As I mentioned, this saves a lot of compute power and money for businesses and individuals alike. Spark NLP, coming back to Spark NLP, you should know that all the terms that I have just discussed about plays into Spark NLP. It takes advantage of pre-trained models and transfer learning by integrating them into its own system and making them readily available to its users. And the beauty of it is that it's open source. A bunch of other terms, I'm gonna go over these very quickly, but I think the most important term that you need to be familiar with in this setting is pipeline. A pipeline is a sequence of algorithms to process and learn from data. And Spark NLP makes use of pipelines, and it's using them in the same way that Spark ML uses. If you are familiar with ML, you are familiar with these terms as well. And if you are not, do not worry too much about it. I just want you to see this and like get some familiarity with these concepts so that you can go ahead and learn about them later. Here's a brief diagram about the things that Spark NLP takes from Spark ML and how the former makes use of the latter's features and customizes them specific for NLP. And please review this later if you get a chance. A pipeline, again, coming back to this idea of pipeline, because we will be seeing in the code that we are about to work with in a few seconds, is probably the most important thing that you need to understand and grasp to understand and work with Spark NLP. A pipeline basically consists of a sequence of pipeline stages, and these are transformers or estimators. Don't worry about them right now, but even if you look at this diagram, you will be able to see that there are certain steps, and these steps needs to be run and executed in order by starting with the data, the raw data that we are going to use to clean up and then use in our models. Some of these things are familiar to you already if you were with us last session, like tokenizing and normalizing and word embeddings. Basically, what Spark NLP does when we give it the data, it starts with it and then it makes some transformations and annotations and then spits out a word embedding that any model that either pre-trained or the one that you implemented can work with pretty smoothly. A pipeline in code looks like this. Each line of this like document assembler and sentence detector and the others will have their own features, as you will see in the code in a little bit. So with that, I know this was super fast and a lot to take in all at once, but if you revisit these concepts and spend some time with the documentation of Spark NLP, you will have no difficulty in using them in an informed way in your experiments with NLP. And please remember that our goal here today is not to understand all the concepts fully, but to give you just enough vocabulary so that you can go ahead and further explore this huge field by using these concepts as keywords as a starting point. We will now show you some examples of how we can use Spark NLP to do sentiment analysis. I'm looking at my time and I'm going to pass it on to Pam right now to get us started.
Okay, let's see. Okay, can you see my screen over here? Or I guess I'm looking over here, but is it visible to you?
Yeah, it looks good.
Okay. So the way that we have done this time, just because it seemed like there could be a lot of Spark NLP, and it was just easier to do this on Google Colab today. So if you can follow directions to get up a regular Jupyter notebook, that's awesome. But this is also another option because Google Colab is free to use if you have a Gmail account. So what I've done is uploaded my NLP tutorial part 2 folder to my Google Drive. And in here, the first notebook we're going to open is, and there's also directions in there that hopefully will help you get set up with Google Colab if it's not something visible to you, but please let us know if you have questions. Anyway, so you can open up, you can right click and do open with Google Colab, and it should open up this Spark NLP Twitter pre-process. I already have it open. This basically builds a little virtual machine for you to run for a session. And so every time you have to reinstall PySpark and Spark NLP, so that takes about a minute. So I've already rerun it, so you didn't have to sit there and watch that happening during this tutorial. But just know that you have to do that every time on Colab. You won't have to do it on Jupyter Notebook if you already have that installed. And the other this one step I wanted to go through with you, this is basically to give your current instance permission to access your Google Drive. You'll have to do this every time that you build you have a new Colab session. So it's giving it permissions to access because we reference some files there. So you'll give it permission, it'll give you this string that you'll have to go back and copy in this authorization code. And that's basically it, and it should be good to go. So now we can run the notebook just fine. Okay. And then I also, with this step, it's importing Spark NLP, which also takes a little bit of time. It's not too long, but it's a little while. So I've run it already, but this will also just verify that everything's installed correctly and you have the right, if you care about the version, that you can check that. Okay, so I am going to go through similar steps, the same steps really that we did last week for pre-processing data, just to show how this is done with Spark NLP. Again, there's so many different ways to do pre-processing, and I think every time you're starting off on a project, you've got to ask yourself questions about what you want to do. Now, there's a lot of cool things with Spark NLP, and there's a lot of pipelines that are already set up to do a lot of this with you. So I encourage you to explore those too. But in this setup, I'm just going to at least have some continuity from last week so you can see how to do things similar to what we did last week. And let's see, I think I did not keep this in the same, I apologize. I'm setting up the paths and I didn't keep it in that same spot. So you'll need to make sure that your paths are set properly too, to make sure everything runs correctly. We're going to use Pandas to read in our initial data frame that I'm using for the examples. It's just the first few lines of Pride and Prejudice, and it loaded it in correctly into this Pandas data frame. And so now we can use it. But actually, in Spark NLP, you have to use Spark data frames in all of their processes. So I'm casting my Pandas data frame as a Spark data frame, and then you can see what it looks like here. All right, and then the next step, that's another different one than we did with NLTK, was it takes in the text it takes it in each string, but it needs documents before, it needs to convert them into documents in order to move into each step of the process. So it has something called a document assembler, which we've imported here already. And now I need to instantiate it. And let's see, calling it, like, no, I don't want to. Need to get my instance. And the way that each of their classes are, you have to set input columns and output columns. So here it's going to take my column with the text and create an output column, which I will call document. I tried to change up some of the words that it would do just to see, but to me it seems like Spark NLP has certain words that it prefers, and text, document, embeddings, those sorts of things seem to work best. So I stuck with what they typically have as their nomenclature. So I suggest that too while you're initially playing with this. That you have a set input column function. It was our text, and we need to set. A lot of this will be very similar with a lot of functions and methods that they have here as setting these columns. Okay, and then we actually need to, now I'm naming it a different data frame for now, but you don't have to. I'll show you what will happen here. We're going to feed it our Spark data frame and get out a new data frame that'll include documents. Okay, what did I do? Did I spell that wrong? Oh, it's assembler. What did I? Oh. I apologize. I am just making all kinds of mistakes. Okay, there we go. And now we can look at what this documents column looks like. So each of these you can view if you want to. It's just really an object that contains that string. What was it? Now I'm blanking on what select. And document result and take, we'll do 3. So they just store the lines in the document, but Spark NLP likes that object, so we have to use that. Okay, the first thing again that we did last time in our steps using NLTK, which now we'll do with Spark NLP, was tokenization. So that's simply breaking up your string into different elements. One of the basic ways to do that is to split on white spaces. Spark NLP simplifies a lot of things in that they have just one function that does that, and then you can set all these settings to do it instead of like an NLTK. I don't know if you remember that we had several different versions of the tokenizer. Well, this time you can just instantiate a tokenizer, and so initially we won't give it any extra settings, but it'll split on white space. And then later on you can see you can actually use the regex tokenizer, but first I'll show how this is done. Let's see, I've already instantiated the tokenizer. So then we'll set the input. This one's function is multiple columns. I'm going to give it the document. And I need to set an output column. Which I'm calling my token. And then this particular type of function needs to fit the data and then transform it. So we're going to have a token data frame, tokenizer.fit, and give it our docdf. And then I take token data frame, token df.transform that docdf. Let's see. That worked well. Okay. Then we can see that it, I just took the top result, but it tokenized it as I expected, and there's still punctuation here. But as I was saying, with using that same tokenizer and getting something similar to the regex pattern like we showed last week, which if you don't remember, that was to use a regular expression to split on. you can actually set a target pattern with that same tokenizer that you've already instantiated and give it a search pattern. So in this case, I'm going to split on alphanumeric cases, and that should get rid of anything extra. So again, I can feed it the same thing in my fit and then transform it and look at the results. And this should remove punctuation. Looks like it did. So that's something similar. It's a similar way to do something that I showed last week. Okay, the next step was to remove stop words. And stop words, again, are the words that you don't think add value to your text. A lot of the times there are things like the, is, a, but there could be any number of words that you decide are unimportant. The NLTK library has a list of stop words to start with. Spark NLP does not have that. So I just saved off that list of stop words from NLTK, and I'm using the same thing here. But you give, the Spark NLP has a stop words cleaner, which will go through and take out anything. You have to specify your list of stop words, and it'll go through and remove those. So it's pretty simple. I like it, the simplicity of it. I mean, it was kind of nice to have a list in NLTK, but at the same time, this forces you to think about it a little bit more, about, I guess, what words you may or may not want to use. But as I said, I was able to get a stop words list pretty easily, so that's also out there too. Let's see, so I'm typing a lot of this together, so it helps slow me down too, but I encourage you to go back, and this gives you practice to do this yourself as well. Stop words cleaner. And we need to do the set input columns. We're going to clean on our tokens. Output column. What am I calling this? Clean tokens. Yep. And then we will actually set our stop words to our stop words list. I don't know if you remember last week I had that list comprehension that I was going through. This is just really simple, that you just give it the list and it does everything. Another thing that Stop Words Cleaner does is you can tell it to do is ignore case, which case may or may not matter to you. I'm mentioning it here because case sensitive, just because I think it's a good thing. A lot of people will, you know, in NLTK with Pandas, you could have lowered it to normalize everything to being lowercase together here, and you may or may not care about case. You might want to differentiate between a word that's uppercase and one that has lower cases, but here we're going to not be case sensitive. And then now we can finally call it. Okay. And this certainly looks much shorter. Let me just also show a select what the tokens look like before this, for the first result anyway. Okay, so as you can see, it had all these words in there and it took out a bunch, or quite a few, so we're just left at what it considered important based off of the list I gave it. Okay, and then final, or I guess not finally, but the last step, at least as far as normalizing your data, is stemming. And to remind you again, stemming is bringing a word down to a root word, and it's a more simple way of doing it that you just chop off the end. So like S's or EDs, things like that, it'll have a rule-based method to go through and just remove those. Spark NLP just has a function stemmer, and again, it'll be up to the latest standards in stemming. There's only one function that you call, and you can just trust that it's going to work really well because they're using the latest and greatest. So we import the stemmer. I've instantiated the stemmer, and now I'm setting my columns just like I've done before. Input columns is clean tokens, and output a stem column. And we will call the transform and take a look at what it does at our first line. As you can see, it did chop off some of these. Spark NLP also has a limitizer, which is also just as simple to use. And they have a function too, which I thought was interesting to mention. Is called a normalizer, which will actually go through and remove what their documentation calls our dirty characters, using whatever regex pattern you've given it. And then also you can give it a list of words, like a dictionary of rules of how you want to normalize things. So you actually specify what you want to do with the words and how you're going to, I don't want to use the word stemming, but you're doing something similar where you're going to return some form of that word. So you would be specific in that dictionary. And I think it's a neat thing to know about, and maybe you want to play with that sometime later. Okay, now this is the word embedding step. So again, what we need to get to eventually is to represent our text as numerical vectors. I'm going to go and use the word embedding model. There's also a sentence embedding model. I mean, that's something to look into. They all work off of, they could be used for different reasons. Here I'm using word embedding, and this particular one that's being called with the word embeddings model is based off of a globe algorithm, which I've linked here for you to look into more if you're interested. But I mean, basically they're taking a model that's been around and researched and vetted in order to now give you numerical vectors. So last time we did something really simple with the count vectorizer, which was just a sparse matrix of counts of words. And this one has a little bit more of involvement, or a little more of a, a little bit more involved method, I would say. So I've imported this word embeddings model, and it's a pre-trained, or this is how you would instantiate it, setting the columns. It needs both the document and the stems. And then I'm going to set my output column of embeddings and import the latest data frame that I have. This takes just a little bit more time, but not too long, because it's downloading a bit of information on what it needs for the model.
I should say though, it is super fast compared to like doing it with other stuff, because Spark NLP shines with things like there's like downloads and stuff, because it's using the Spark on the back end.
And thank you, Fatma. It does do things a lot faster, which is pretty cool. Like, I think one of the things I'll show at the very end is the difference, if you remember from last week, but that was the only thing I could think of that was a comparative that you could see. But I'm sure you'll see it in a lot of cases where it's fast. This is just a printout to show that it actually has a numerical vector now in there. It translated everything into these vectors. Okay, so finally I want to use a pipeline to go through and pre-process all of our tweets data. So last week, if you remember, we created a for loop that did all these steps. It went through every row in the data frame and processed the whole thing, but I didn't even run it with you there because running it takes about 10 minutes. So this is what I was wanting to say, that I had this comparison, because once you set up this pipeline and use Spark NLP to do all these steps, it's just really fast, and it's doing the entire data set. So I think it's pretty cool. So here in this cell, all I'm doing is importing my COVID tweets, again, the same data set that we used last week. I need to rename the column, the tweet column text, because it works better that way. And then I'm casting it to a Spark data frame, and we'll just take a look at it to see how that looks. And it's all there. We've got what we need. A few extra rows, but I'm going to leave them in there, or extra columns. I'm going to leave them in there for now. And in this cell, I'm just importing the pipeline. Now, if you're starting with a pipeline, in this particular notebook, I've already instantiated everything I'm going to use in the pipeline. If you're starting with this step, you'll actually have to go through and set up each of these pieces before you can add them to the pipeline. So again, that's like with the document assembler, we had to set the input column and the output column. The tokenizer, I put in my search pattern already. So all those things you'd have to do. I just listed them here because I'm going to use them again, but I'm not going to re-instantiate again. So in this cell, we're just going to set up our pipeline together. I'm calling it NLP pipeline. That's right. And we will use the pipeline. And you just have to give it stages. Okay, so I'm going to use my document assembler, tokenizer, stop words, cleaner, stemmer, and the word embeddings. Got everything. So you've just told it everything you want to include, and you've instantiated each of these. And then you can fit your Spark data frame to create the model, and now you can transform it or train the model, I suppose. And it does all those steps, and this is just, to me, it's just really fast, so I think it's great. Based on what it did in the for loop, it's doing a lot in the background to make this efficient. So we have our document, column, token, clean token, stem, and finally our embedding. So now you could actually go back and use this to use in training models or however you want to. But as I said, and Fatma will go over now, some of the advantages of Spark NLP's pre-trained models and what you can do there. So thank you.
Thank you, Pam. All right. Okay, so what we're going to do next, in your folder, you can navigate to this file called Sentiment with Spark NLP. I have already have my file open in here. And what we're going to do here now is to show you how you can use some of the pre-trained models that Spark NLP is providing you right out of the box, as well as how we can train it on our own data and then use the power of transfer learning while we are trying to predict some sentiments in a notebook. I'm sorry, in a data set. Just like Pam did, you're gonna run your setup in your Colab. If you are using Colab and if you are using Jupyter, you don't have to do this, but you should have already installed Spark and make all the settings for the Java JDK. I should have probably done this earlier. Okay, it's actually not that bad. And the reason we wanted to use Colab as opposed to Jupyter Notebooks tonight is because first, we didn't want you to download a bunch of things if you're not going to be using them later, or if you don't want to use them later. And second, if you are not familiar with Colab, you can actually use a GPU for free, which is a great thing to experiment with if you are playing with models. And the only thing is that it's not persistent. It will go away. Like if you don't save your checkpoints or weights or learnings, it will go away after 12 hours. But if you want to change your runtime, you just go to runtime and say change runtime and set it to GPUs or even TPUs that you can use for free, which is a great service. And another reason for Google Colab today is that if you want to go like dive into Spark NLP, most of their tutorials are using Colab because they're also taking advantage of some of the GPUs. and it's a good place to start playing with Colab for that reason too. Okay, so I have downloaded Spark NLP in here and Apache and all that, and then I have set up my Google Colab. Now that I'm ready to play with the model, I'm just going to do one final check to make sure that everything looks good. If I'm not getting any errors in this line, that means everything is ready to work with. Yeah, it seems to be taking a little bit of time, but it's not going to be too much. Okay, so the first thing we are going to do, like we mentioned, we are going to use one of the pre-trained pipelines that Spark NLP comes with. And the way we do that, I'm just going to set it up without having to do all the steps that Pam has just done for us. I'm just going to use this thing called Analyze Sentiment, which Spark NLP comes with. And then I'm going to give it the language, which I forgot to mention. Spark NLP actually supports multiple languages, which is a great feature to have. Analyze sentiments as one of the pre-trained pipelines that Spark NLP provides that we can use with our own short data sets or, okay, did I make a mistake in there? This should only work. Oh, sorry. This should have been lang. Okay, let's make it bigger. Okay, so this is where we are in initializing our pipeline, and now coming down to this cell, what I'm going to do, I'm just going to give some random sentences that I actually took from our data set on COVID-19 tweets. And in this data set, it's a list of sentences, and I have one sentence here, actually two sentences in one, and then another one. So a total of 2 items in this list. So this is my little tiny data set that I'm going to use with the pre-trained pipeline Analyze Sentiment that I'm initializing here right now. And the other way you can do this, if you want to, at some point you will have to change it to a Spark data frame. And if you want to do that, this line 4 is going to show you how to do that as well. So what I'm going to do here, I'm going to set the pipeline to annotate what I have just created as my data set above. And then we will see what it does in terms of what kind of sentiments it's going to give us. And if you ask me, the first sentence, as you can see in your notebook, is not necessarily too positive or negative, but we will see what this model does for us. Okay, so as you can tell, it just break the sentences after every period and then said for the first 2 sentences negative, and then the last sentence also negative, which is actually pretty accurate. In this one, right now we don't have the label neutral, but going down we are going to see that Spark NLP takes care of that too. And if there's a chance that the language is, I'm sorry, the data, the text can be neutral, it will identify it for us very quickly. If I run result right down here, it's going to show me all the stages that the annotator that I have used here has done. Checked here in this case means it's checking for spelling, which is a great feature to have, and we can have it in other libraries too, but this is pretty straightforward. And then it's telling me what document it looked at and what sentences it broke it into, and then giving me the tokens and sentiments for each of the items in my list as I use my little tiny data set. You can go ahead and inspect this. It's pretty straightforward, I would say, in terms of how it is doing the annotation and then telling me how it got to the sentiment that it assigned to the sentence. So this first section is how you can just use Analyze Sentiment on your own sentences if you don't want to work with a data set that you need to clean and process or annotate first. You can just call this pre-trained annotator or model, and then you can just use it on your little data. Coming down here, we are going to do something a little bit different. We are still going to use some of the pre-trained model power from Spark NLP, but we are going to use it on our own data set. We will be training their pre-trained models, and we will be training it on our own data set. I'm looking at the time, so I might be going too fast. My goal is to finish this notebook, but we have provided some comments, so I'm hoping it will be helpful. Just like we did in the previous steps, we are going to initialize our data, our tweets data set. Please note that this actually this yeah, I forgot to fix this either. This path is going to be proper for your own setting, so you might want to make sure that you give it the right set. I'm going to see if my data set is here, and if you were here last time, you will remember that we had some tweets, and then we had some sentiments that we had labeled this data set using NLTK using NLTK's Vader model. As I believe Pam mentioned that we need to use the column name text for Spark to understand our text. In our existing data set, that specific column is called tweet. So I'm just going to put it in a language that Spark DF can understand. Going down. So I'm just going to rename this column here. And if you encounter this issue that where your the text that you are trying to get the sentiment of is called something else, this is a step that you will need to do before you can proceed with your pipeline. Okay. Okay, I'm getting all kind of errors today. I'm not sure what I did wrong in here. Okay. Oh, sorry. This is actually supposed to be plural. Okay. There it is. So I'm going to look at it again. Oh, another thing that I have done here in line 1 is I just got rid of all the other columns that I don't really need for this specific task. We could have done this with NLTK as well to reduce the size of data. If you have like a really huge data set, this is something that you can do. Just get rid of all the things that you don't need or doesn't have an influence or impact on the sentiment that you're trying to get. So this is my still Pandas data frame, which has only the text column and the sentiment column that has been labeled earlier. What I'm going to do coming down here, I'm going to split my data set into training and test sets. Remember, we have done this with scikit-learn last time. This is just another way of doing this. This time I'm using NumPy to split my data set into training and testing data sets. This is going to allow me to work on the training while I'm training my pipeline, and then test it on the test data set that I am going to save in here. Again, you can also use scikit-learn here if you want to, but what I wanted to do here is like I'm trying to not load as many things as I'm trying to load as little or few libraries as I need to, and I think NumPy is more straightforward and used more in this kind of steps, unless you are using scikit-learn for your model specifically. I'm going to look how the division went. And I'm seeing that in my training set, I have 3,625 rows, which each is a tweet. And then in my test set, to make sure, okay, this looks pretty good. And because I divided it 80 to 20, you can use a different ratio depending on what outcome you would like to get from it. And then I'm gonna see here, okay, everything still looks good. These little tests for the data sets is actually pretty useful. It's like get ahead of the data set to see if it actually looks like what I assume it to be. Okay, so this step is like Pam mentioned, is where we are converting our Pandas data frame into a Spark data frame. Spark data frames are basically circular tables behind the scene. That's what Spark ML and Apache Spark uses. If you are familiar with SQL and its methods, this is going to be very familiar to you. So right now I'm converting my Pandas train data set into a Spark data the data frame into a Spark data frame. And I'm going to do the same thing for my test set. And it's going to be test data set type. And then I'm going to set it to stir. There are some issues that I have been having with the SQL tables and then Spark data frame. Sometimes if it doesn't recognize some of the characters in your data set, it might shift some of the columns, might create some errors. You might want to look closely if you encounter any of those issues. I hope you won't today, but you might. Okay. Now, as you can tell, it's the same data set, same columns and labels, but this time we have our Spark data set that we can further use for the model. Coming down here, I'm going to do a few more imports. I pulled these imports down so that you can make the connection with what's coming next. Some of these things that I will be needing to set up my pipeline, and because we are almost running out of time, I'm not going to go into details of these steps, but this is very similar to what Pam showed to you guys, but this time you can see the difference that I'm using this universal sentence encoder pre-trained model coming from using another pre-trained model from Spark NLP to use the encoding. This is a very powerful one. I will encourage you to look at it, and it's based on BERT and all the other very powerful language models. Here I'm setting up my sentiment. This time is called approach because we are still doing the annotation steps, but going down, if we have enough time, you will see that we are actually going to save and load this, and it will turn into a model rather than an approach, which is another term that Spark NLP widely uses and incorporates. I'm going to run this line, and this is going to take a few seconds because it's a little bit larger because I'm using the data set and then universal sentence encoder, which comes with a little bit overhead, but again, this is way faster than compared to some other tools and libraries. And if we were to run this on GPU, which is, I probably should have done that. I'm not using GPU right now. This is on CPU, and that's why it's not super fast. But you can use a GPU while running this notebook on Colab, and then get all the efficiency of using a GPU in there. While it is running, what I am doing on this line is actually fitting the model. In other words, training the model. I'm giving it my trained data set that I have created above, and this is going to train my model and save it into this pipeline model. You can name this anything that you want. Okay, I think we're gonna make it. I'm looking there, a few more steps. And if there are things that are not clear to you guys, you can always reach out to us. We will be happy to answer any questions that you might have later on. And I will be putting the slides in the GitHub repo as well, that you can revisit if you would like to clarify points that might be helpful. After that, coming to this line, what I'm doing here, this syntax is a little bit confusing, I know, but this is how we are going to do it using Spark NLP. We are going to save our model to use later. This is something that you can do. If you are familiar with like machine learning models and training and all that, this is like saving our weights and checkpoints in a way, so that we can load it into a different setting if we want to later on. And this is, if you are using PyTorch or TensorFlow or any of those frameworks, this is the same thing, loading and saving a model. Now, I have saved my model. I have trained it on my own data set using the pre-trained models from Spark NLP. And what I'm going to do here, I'm going to test it on for prediction. I'm going to load it back to see if this is actually going to do well in the data set in the test set that I will give to it. you will see that some of the steps and attributes are the same while we were doing the annotation above, but this time we do not have an approach. We have a model that we have previously saved here, and we are loading it back to the system to work with. Here, I'm going to give it a couple of random sentences to see what it is going to say. As you can see, this is basically doing some predictions on the data. Not my test set yet, but I will get there as well. And the way you can do that is, yeah, we need to train it on this test set that I have just given it, and then we need to transform it. Like there was a question about transforming. Why are we transforming right now? Which is a great question. It makes sense, but in every pipeline stage in Spark NLP, we need to do the transform so that it actually executes what we were trying to do. Coming down here, I want to see what it is going to tell us. Okay, so looking at these sentences, this first sentence is positive and the second sentence is negative, and it was able to predict it correctly with a lot of confidence. If you look at this metadata, it's going to tell you how confident this model was when it is labeling these two sentences negative or positive, or giving it some of the sentiments. Okay, we are almost out of time. I might just rush through this or just leave it as it is. We have provided the solution files in the folder as well, but I'm just gonna see if we can actually finish it in the next couple of minutes. What I am doing here, this time I'm giving it the test set that I want the model to predict. And what I wanted to look at is to look at the sentiment, the text. This one is actually going to display both the sentiment pre-labeled data set sentiments as well as the prediction that the model has done. Okay, I think I got this right, I hope. There it is, great. Okay, so the sentiment column is what the test set came in. However, when we are doing the training, of course, my model doesn't see that. And the result is what the model that we have just implemented is telling us. This is, we are seeing that some of them are the same as the previous sentiment that was done by Wader. Please remember, the Wader wasn't really, it was a good one, it was decent, but it's not perfect. So some of these sentiments may not be, like if you were to go line by line and read all the sentences, we may not agree that one is positive or negative. And the results from the Spark NLP model is going to be stored under the result column. Okay, I actually was, I'm glad I did that. I was going to leave this to you to do some of the measurements and evaluation of the model overall, how it has done with the test, with the data that we have. And you see that this is the issue that I was telling you about that you might run into with Spark data frames. Something happened here in this line. It wasn't able to recognize one of the characters and it just shifted the text into the sentiment column. This needs to be, of course, like cleaned in more detail and looked into, but it's not earth-shattering right now in this setting. But these are the things that you need to watch. So we are providing the solution to this, and go ahead and play with it if you want to, and look at the accuracy score and some of the other metrics that scikit-learn provides, and we have covered in the previous session. With that, I'm gonna stop. Olga, we are on time, but yeah, sorry, it took too long. Thank you.
No, that was perfect. Thank you.
I wanted to leave some time for questions, but there was a lot to cover. So
I guess if you want to, we have a couple of questions on the chat box. If you want to address any of them, or it's up to you. Or actually, also the
okay.
I have unmuted. You could also speak up if you want. Just a couple of questions, but let's see if we make it.
Yeah. So I'm seeing question from Ashar. In real industry like station, what kinds of models normally are used? Pre-trained models like BERT, ResNet, or simple models like random forest? I would say, of course, I would say that pre-trained models, especially with the efficiency and power that they have gained in the last couple years, are most of the time the number one choice to go, because now that all the businesses can use transfer learning, they do not have to train like huge data sets or label huge data sets, but they can also take advantage of all that learning that these models are providing. However, for each businesses and specific industries, there might be like different choices and different factors that plays into that might change this decision. But I know that BERT and like some of the more recent ones, even like ExcelNet and Roberta and among others, are pretty popular right now. So that's what I will say. But again, scikit-learn models are also very practical. If you don't want to do like a lot of deep learning type of learning or like modeling, then you can very easily use scikit-learn and get great results as well. Thank you guys. Thank you everyone for being here tonight. I hope you enjoyed it, and hopefully you learned and you want to go and learn more. Spark NLP is actually really efficient and gaining a lot of popularity. It's one of the good ones, and I would encourage you to look into it even more and into the documentation. They have great documentations and tutorials as well.